arithmetic. Now, let me just start out with an example. Let's say we take the 4 consecutive natural numbers, and I'm just arbitrarily starting at 3. Okay, 3 times 4 times 5 times 6. Y'all, again here, the dot just connotes multiplication. And we add 1 to that. Okay. Now, what do we end up with right here, folks? That's 1260. That's 361. I'm doing the arithmetic here, folks. I've seen this quite a bit, so I'm not going to bore you with pulling out a calculator. Now, notice this is equal to 19 squared. Okay. No big deal so far. We just took 4 consecutive natural numbers, added 1, and we got a perfect square. Now let's try another one. Okay, let me put a comma here, y'all. I'm getting used to my new little tablet here. This thing's pretty cool. It senses pressure. It's a lot better than using the mouse. I'll tell you more about that device later on. But let's start with 4 this time. So let's do 4 times 5 times 6 times 7. Again, we have 4 consecutive natural numbers, and we just started at 4. Now let's add 1. Okay. Now let's just see if we can do this in our head. 5 times 4 is 20. 20 times 6 is 120. And 7 times 120, 7 times 120 is 840. So this would be 841. Now, y'all, I'm taking a large guess here, but that's equal to 21 squared. Okay. That's 21 squared right there, folks. That looks like a crazy looking 11, but that's 21 squared. Let me see if I can work with my little tool here and erase a little bit. I'll erase that. Let's go back here, folks. Okay, that's equal to 2, 1 squared, like that. Okay, so we see a pattern here. Now this, I could do more numerical evidence, but we took 4 consecutive natural numbers here, 3, 4, 5, 6, multiplied them, added 1, and got 19 squared. Here we took 4 consecutive natural numbers starting at 4, multiplied them together, and we got this, right? So in both cases, we got the square of some number. Now let's look at the more general case here, which is really quite interesting. Okay, rather than call it 3 or 4, I'm going to call it n, right? Okay, what's the next natural number? N plus 1. Okay. What's the next natural number? N plus 2. And so we're just writing down kind of a generic, not dependent on a particular starting point, plus 1. Okay. Now this is exactly what we've been doing, except we're just dealing with an arbitrary starting point that's not named. So n plus 1, n plus 2, n plus 3 plus 1. Now a little bit of algebra here. I'm going to pair the n with the n plus 3. You can do that. It's called the commutative property of multiplication. So right here you have n squared plus 3n. Y'all, I'm just bubbling with this new toy of mine. It's a little tablet that has a pressure sensitive stylus. It's really cool. So what I did, n times n plus 3 is this. Okay. And again, y'all, I'm just pointing here. What I did is I took this and this, right? Okay. Now what's left in the middle here? Just from elementary algebra, in the middle you're going to have n squared plus 3n plus 2. Okay. Very good there. Okay, now we still have plus 1. Okay. But if you take a look here, folks, if you take a look here, and this is probably the hardest part right here to recognize this. This is really the difference of 2 squares. Now let me write this out for you. You're going to have n squared plus 3n plus 1 quantity squared minus 1 squared. And again, this is the part that's a little bit of a challenge to see, and you can just work through that on your own. It's kind of, I don't want to clutter this thing up too badly, but this is a minus b right here. This would be your a minus b piece right here. This is your a plus b piece right here, okay? And that's equal to a squared minus b squared. This is a squared minus b squared. Again, I can fill this in, but it would get a little cluttery. So I'm just gonna write down the final result here. All right, now you may not be as excited as I am about this, but you see what we've done here is we started with, let me put equal signs here, folks, just to keep things alive. This is equals to this, equals. And so we got the product of 4 consecutive natural numbers plus 1 is actually equal to a perfect square. Now, let's just take a look at this special case over here that we did numerically. For that case, our n was equal to 4. Okay, our n was equal to 4. So according to this, if you put n equals 4 right here, you would get, let me write this for you, 16 plus 12 plus 1 quantity squared. Okay, folks, but what is that equal to? That's equal to 29 squared. So you see, I made a mistake up here, but I was still right in the overall approach. See, I just tried to do this in my head right here, and I got 21. I was mistaken. That's 29 squared. So let's come up and erase that. That's actually, folks, 29. See, math is very oops. Why this thing, there's just some awkward things about this stylus. That's 29 squared right there, folks. And I made the mistake. I would just try to do it in my head and got 21. I was completely wrong about that. You see how these two things line up? So again, folks, that's the proof. That's the general proof that the product of 4